different, then they will be false. And the reason is because if A is ever the true antecedent and a false consequent, then it's going to be false, right? And now, even though that's false, true, true, false plus false, true is false. And so that will be a line in which it will be false. The only time, if one of them, because one of them will function as a true antecedent while the other one functions as a false consequent. And so anytime that happens, it will be a false statement. So with A triple bar B, if the antecedent and the consequent are the same, then it will be true. If the antecedent and the consequent are different, doesn't matter which way, then it will be false. Okay? Any questions on that? Now, what happens is you have 5 of these little charts, right? And we have A triple bar B, we have A horseshoe B, we have A plus B, A wedge B, and bar A, right? And so one of the things, like if I were going to be teaching this class in the classroom, just like I told you, if I were teaching the previous material in the classroom, the translations, I would make you go home and memorize what all the chart, what all the different symbols meant and everything. The same thing is true here. If I were going to teach this in the classroom, the first thing I would do is I would make you memorize all these 5 truth tables. I would come in and I would give you a sheet of paper, and the sheet of paper would simply have, on it, it would have a little chart and say bar A, and it would have some space. You'd have to fill it out, and then there'd be A plus B, and you'd have to fill that out, and then there'd be A horseshoe B. All 4 of these would be on there, and you would have to fill that out and do it at the beginning of class, right? Now, the case is there's 2 things to say about this. One is that basically, you can, I go over this, what these mean, but once there's a little bit of, once you know what it means, you know what the language means, you know why certain ones are true, certain ones are false, at least some rough idea of that, right, since I've gone over it. But to a certain degree, from here on with truth tables, you can forget everything you just learned, and as long as you can remember that when you have A plus B, they both have to be true, then the plus sign is going to be true. Once you memorize that, once you know that, you can pretty much do the truth tables. You don't even have to remember what everything means. You can kind of forget the ordinary language from which it comes. So if you are going to do this, as you're doing problems in the book, as you're doing problems on the test, I would recommend that you write down all these truth tables on a sheet of paper, and that way you can check it if you need to. But there is something about you don't actually have to know all of it. Does that make sense? Okay. Now what happens is truth tables are basically an elaborate way to look at every possible truth and falsity. But in some cases, you may get a statement in which you already know, and I think I have a couple questions on the exam like this, but questions where you already know, suppose I tell you the letter A is going to be a true statement, and the letter B is going to be a true statement, the letters C and D are going to be false. Okay? And then suppose you have a statement like A horseshoe D plus C triple bar B parentheses, let's make it a little more complicated, brackets, okay? Something like that. Does that make sense? Can you guys read that? It's A horseshoe brackets D plus parentheses C triple bar B close parentheses close brackets. Well, if you already know the truth value of the parts, then you can evaluate, is this a true statement or not? I don't know. I just wrote it down as I was going. I don't know if it's true or not, in all honesty. I have a feeling it's probably false, but I don't know. Okay? So what you can do is you can actually just start off, you can say, okay, A is true, D we already assigned as false, C we assigned as false, and B we assigned as true, right? So these are all statements. We can just sort of enter that in and so take out the letters. Okay, and then rewrite it like that. So it's now T horseshoe F plus parentheses F triple bar T. Okay? So what we can then do is we can say, okay, well, order of operation. What do you start with? Well, you start with the thing that's the smallest thing, the thing that's in parentheses, right? So you go parentheses, then brackets, then the main operator. So right here, F triple bar T is, what's F triple bar T, if I remember?
If and only if?
Yeah, that's what it means. But if you have F triple bar T, what's the triple bar?
F.
F, that's right. So if you look at that chart, and you have, when you have, T triple bar F, that's always going to be a false statement, right? Right. Does that make sense on the chart? If you look at the chart I just put up there a minute ago. Let me find it. If you look here, so if you have tree and false, it's false. Does that make sense?
Oh, okay, yes. You just plug in. Okay,
Yeah, okay.
Plug it in.
Yeah, you just plug it in. That's right. That's all you do. So that's going to be false.
So then the F, you bring down the F. And F is false. Those together is the plus.
The plus F is false. So it's T horseshoe F, which is? No, if the antecedent's true and the consequent is false,
okay.
It's the only time it's false. And so you make it false. Does that make sense? So you're just kind of replacing them as you come down. So the first one, A is true, then D is false, C is false, B is true. Then you do F triple bar, T is false. Then you have false plus false. And then you keep the T horseshoe out front just for bookkeeping. And then F plus F is false, so it's T horseshoe false. And then true horseshoe false is false according to our chart. Does that make sense?
Yeah.
Now that's if you know the truth values, right? Now if this were the case, now in that case you know the truth values, so you can do that, and you can do that fairly simply. It's easy, and now you know that if anybody ever tells you, and Al is here, and Becky is here, but Dave and Carl aren't, and they come up to you ever and they say, well, if it's the case that Al is here, then it's the case that that Dave is here, and if Carol is here, then they give you this elaborate thing, and you already know who's here and who's not. You know that's a false statement, right? Okay. Now, what does that get you? I don't know, but that gets you something, right? But that's all nice and good if you know the truth values. But suppose for a minute you don't actually know the truth values, right? Suppose you don't know any of those truth values. These pens kind of seem to dry out quickly. Anyway, and suppose you had A horseshoe D plus C triple bar B. And suppose you said, well, in what situations would that be true and in what situations would that be false? Well, then we could use a truth table to figure that out. So how many letters are there? How many unique letters are there?
This is where I am. Is there any conclusion in here? That's the problem that I have.
The conclusion? Well, the first thing you do is you evaluate statements themselves. And what we're going to do is a statement. Sometimes you have statements that no matter what the case is, that they're always true, and they're called tautologous. And sometimes statements are constructed in such a way that no matter what, they're always false. And then there are statements in which then there are statements that are constructed in such a way that sometimes they're true and sometimes they're false. And those would be called contingent statements. And whenever they're always true, we call them tautologous, or logically equivalent, or logically, I think we should say tautologous. And then the other one is logically contradictory. And there's statements that are always going to be true. Like examples like if I say, if you say something like a this or that, and they're the exact opposite, like the door is open or the door is shut. Well, yeah, Einstein, of course the door is open or shut. It's one or the other, right? But then there's statements that are always contradictory, like, well, I'm either pregnant or I'm not pregnant. well, that's always going to be true. Yeah, you're either pregnant or you're not pregnant. There's no real other option on this matter, right? I mean, I suppose you could be but I mean, even then, it's like, I mean, there's really no, I mean, that's what you are. You're either that or you're not. I mean, even if you're in the middle of like delivering the baby, you're either, you're pregnant until the baby's out of you, right? And then there are cases where that tautologous is also cases like, one of my favorite tautologies is like, what's a statement that's always true is people always say, it's always in the last place you look.
Why would you look?
Well, who keeps looking after they found it, right? So it doesn't matter if it's the first place you look, it's always in the last place you look, right? I mean, you ever lose your glasses or your phone or something like that, right? And you're like, where in the world's my phone? And then you find it and you're like, I found it. Who wants to go look underneath the couch? No, nobody does it. Doesn't matter if the first place you look, it's always the last place you look. So the case there is that's what we call a tautology. It's always true. And there are some statements that are constructed in a way like, I'm pregnant and not pregnant. Well, that's always false, right? And so that's just a way of evaluating it. It's not a particularly useful thing other than occasionally you can find things you're like, well, that's a tautology, or that's something that's always true, and that has some value. Okay? But if this were the case, you have 4 letters. So you have 1, 2, 3, 4 unique letters. So 2 to the power of the 4th is
16.
2 times 2 times 2 times 2, which is 16. So we would need 16 lines to do this. I am not going to do this.
Yay.
What's that?
This is a question. If you wanted to find out if it's valid or invalid in here,
Mm-hmm.
and it's at the bottom of the line in the indirect truth tables, you
Right.
have to go all the way down. Like you just choose really crappy because your luck is bad, and you choose all the, you choose true, false
Right.
to start with.
Right.
So, is that just luck?
Well,
It says it's arbitrary to.
yeah, I always tell people always be consistent in doing TF, TF, and then the next letter do TT, FF. Next one you do 4 T's, 4 F's, last one 8 T's, 8 F's. But yes, if you're judging validity, the case is we're jumping a little bit ahead, but with validity, the way you judge validity is you can actually look at an argument and you can say that basically the way we determine validity in logic or deductive validity, the way we define deductive validity is it's a statement in which or basically we don't really define validity, we really define invalidity. And invalidity is a statement in which the premises are true and the conclusion is false. A deductively valid argument is an argument in which if all the premises are true, then the conclusion must be true, right? So the way you prove invalidity in this is you find an argument in which you've proven that there is a case where the premises are true and the conclusion is false. Because if it's possible to have true premises and a false conclusion, then it's an invalid argument. Okay? So if I can have an argument in which everything I tell you is true, but yet the conclusion is still false, that's an invalid argument. Suppose somebody comes in and they say, well, this is true, and this is true, and this is true, but yet the thing they're trying to prove to you is not true, then they've given you an invalid argument. Bless you, by the way. They're giving you an invalid argument, right? That it's only valid if all the premises are true and the conclusion is true, or possible for that to be the case. Okay? Does that make sense? And so what we can use truth tables is to evaluate validity, because if we can ever find an argument in which all the premises are true and the conclusion is false, then we've proven that it's invalid. Now, you say, you could go through this whole thing and you could spend like 64 lines, 32 lines, what was this one, 16 lines?
Mm-hmm.
A mere 16 lines, that's hardly anything, right? I mean, it's not fun till it gets to 32 or 64, right? Anyway, and so what happens is that as far as it goes, if you get to that where it's like that many lines, yeah, it takes forever, and you could find on line 32 that there is true premises and a false conclusion. And that will be very annoying, right? But there is what we call an indirect method, in which